In lesson 5.5, we're going to tie together some of the things we've been learning about in this chapter, which are means and medians, with some of the topics that we learned first semester, which are conducting hypothesis tests. So just first to quick review the process of conducting a hypothesis test. Our first step involves stating our hypotheses. We have two hypotheses, the first of which is the null hypothesis, which we abbreviate H naught. The null hypothesis, remember, is a claim that there is no difference in an athlete's or team's ability in two different contexts. So last semester, we looked at things like home games versus away games, right? Where we were looking at a team's ability to win in home games versus away games, and we started by assuming there was no difference. HA is what we call the alternative hypothesis. And this is a claim that an athlete's or team's ability is greater in one context or another. So maybe we have evidence that suggests that teams perform better in home games than away games. Step number 2 is we want to find what's called the test statistic. And this is a measure that we calculate from an athlete's or team's performances. So we might have some data, for example, that allowed us to calculate the proportion of the games that the team won at home versus the proportion of games that they won away. Step number 3 is we want to conduct many simulations of the situation, assuming that there is no difference in the ability from one context to another. Last semester, we did that using playing cards. I think we did it a couple other ways, maybe with spinners or something. But primarily, we're going to use an applet to conduct those simulations. And I'll show you how to do that today. Step number 4, we use the test statistic to find the p-value. The p-value is the probability or the proportion of the simulation results that are equal to or more extreme than our test statistic. So we locate our test statistic on the number line and we count the number of the dots that are to the right of that test statistic if our test statistic is positive. Finally, we make a conclusion. And remember, this is based on the p-value. So if the p-value is low, which we define as less than 5%, we reject our null hypothesis. And that means that we have good evidence that our alternative is true. And if p is greater than or equal to 5%, we fail to reject the null hypothesis. And that means we do not have good evidence that the alternative is true. We're going to use the data that we collected in chapter 4 when we went down to the golf room and we tried out the two different types of putters. So we have the data here for the long and the short putter, and I also gave you a dot plot to look at. And just based on initial results, it might look a little bit like the long putter performed better. And remember, we're measuring the distance from the ball to the cup. So actually a shorter distance indicates a better performance in this case. So there's not a real big difference between the two, but it does look a little bit like the long putter performed better. But what we want to know is this difference significant? Or was it maybe just something that happened by random chance? So we're going to conduct a hypothesis test to see how likely these results are. So first, we'll start by writing our hypotheses. And in this case, our null hypothesis will be that students have the same putting ability with the long and the short putters. Remember, we're assuming that ability is the same in both contexts. Our alternative is that students have a greater putting ability with the long putters. Now what we want to do is calculate our test statistic. And in this example, what we're going to do is use the difference in the mean distance for each putter. And we're going to do the short putter versus the long putter. Because one way to kind of get an idea of how students performed with each putter is to calculate the mean distance from the hole when all the trials are done being conducted. So I'm going to let me go back here a second, and I'm going to put the data for the short putter into list 1 in my calculator. And I'm going to do the same thing with the data for the long putter, but I'm going to put that into list 2. And then I'm going to let my calculator find the mean for me for each set. So the mean for the short putter is 25.7. Notice I did a little subscript S there so I can remember which one is which. The mean for the long putter is 21.4. And again, notice that the long putter has a smaller average, which means students in general were closer to the cup when they putt with the long putter. And now I've defined the difference as short minus long. And I did that only because I wanted to get a positive difference, but you could certainly subtract the other way. So my test statistic then would be 25.7 minus 21.4, and that gives me 4.3. The 21.4, by the way, I rounded that. The mean actually is 21.375, but we'll just typically go to one decimal place. All right, so there's my test statistic. Now, I already ran a simulation for you, and notice that the dot plot here that shows our results says simulated differences in means. And so what that does is it takes all of the data between the two lists, it kind of scrambles it up, and it recalculates the mean difference. And notice that in some of the cases, like over here, our mean difference was negative. And remember, we are doing the short putter minus the long putter. So short minus long, if that gives us something negative, what that tells us on this side of the graph is we actually had some simulations where the short putter performed better. Over here on the positive side of the graph are the situations where the long putter performed better. And we had actually one trial where the difference was 0, which meant that in that one simulation, we had exactly the exact case where the mean differences between the two groups was identical to each other. Well, anyway, our test statistic was 4 point something, right? So we need to find 4.3, I believe. So we need to find where that's located on our graph. And that would be right about there, right? It's kind of hard to tell from the scale. And so our p-value then is going to be everything that is to the right of that. So that would basically be all of those dots right there. And we would find the p-value by counting all of those values up. And let me erase this real quick here. And there's a lot of them there, right? And so remember, what we're looking for is it greater than 5% or less than 5%? I actually went ahead and counted all those dots, and there are 45 of them. So our p-value is 45 out of 100, or 0.45. And that is definitely greater than 5%. So our conclusion would be that we will fail to reject the null hypothesis. Our null hypothesis said that students had the same ability. So if we fail to reject that, that basically means the two putters are the same. So that tells us there is not good evidence that students with long putters have a greater ability than students with short putters. And there are always different ways that you can word that, of course. That's just the way that I did it for this example. All right, so there's one example. And in the next one, I would like to show you how to use the applet. So I'm going to stop this video now, and then video number 2 will walk you through the second example and also show you how to use the applet so that when you do your investigation for this chapter, you'll know how to use that.